All right, so I can take your questions, but I do just want to give a bit of an overview on what we're going to have for this test. We'll have from chapter 1, it'll be sort of equally divided between chapters 1, 2, and then a little bit of 3. So you'll have, actually, you have more chapter 2 than of anything else, because you have the 8 free response questions, which are from chapter 2, and then you also have, I don't know, in the multiple choice, you have less than 10 from chapter 1, and then about, I don't know, 7 or 8 from chapter 2, and then there are 4 or 5 from chapter 3. And from chapter 3, it'll just be the vectors. Okay? Are y'all with me? Everybody's got their heads buried in computers. Are y'all with me? Okay. So, chapter 1, remember, we'll have dimensional analysis, standards, unit conversion, estimations, and that's all for chapter 1. In chapter 2, which is mainly kinematics, so we'll have some kinematics calculations, some kinematics conceptual, and then we'll have graphing. And in the graphing, you'll have both qualitative. That's like the graphs where I show you the curved line and ask you what kind of motion is this representing? Is the acceleration positive or negative? We'll look at some examples like that. And you'll have some quantitative. And the quantitative, that means I show you a position versus time or velocity versus time graph, and I ask you for some numerical value from that. So for example, what is the instantaneous velocity from a position versus time graph? And in that case, you would take the slope of it. So you have graphs that are both qualitative and quantitative. And I think that's it for chapter 2. And then for chapter 3, you'll have 4 or 5 questions. One will be doing the sum of vectors, the vector sum, and numerically, doing it numerically. We'll do one like that today, where I give you 2 vectors and I ask you what is the magnitude and or direction of those 2 vectors. And then you'll have to do a graphical sum. That's where I give you 1 vector, give you another vector, and ask you which result is the sum or difference of those 2 vectors. There's a question like that on every exam. So likewise for the other, there's a question like that on every exam. And then you'll have some conceptual questions about vectors having to do with the components, with what quadrant they're in. There are a variety of those that are in the concept test and then also in the past exams. So I recommend that you, first of all, study the past exams. If there's a topic in those exams that you just left with and you don't understand, you can go back and revisit your notes, revisit the example problems that we worked. You can study the concept test. That's a good way to study. And then also the homework questions in the back of your chapters are good, especially for those free response, because they don't give you options for those. You say about the free response though that I once had those questions embedded within the multiple choice. So if you're practicing the old exams that don't have free response, practicing those multiple choice questions will help you on the free response, because I really just pulled those questions out of the multiple choice and offer them in a free response format so that you can get partial credit, show your work. It's just a better way to show that you know what you're doing. Okay? Have particular questions that you want to deal with? Okay. All right. Let's look at an example. Let's see if there's one here. Okay, this isn't a cube conversion, but it's a squared conversion, so I think it's a similar thing. Here, I asked you to find the area of a piece of paper in square centimeters. So the first thing that you would do here is figure out what is the area in inches. So 8.5 times 11 That says that is 94 square inches. That's your first step. By the way, notice that that answer is there, so be wary. Be careful when you're going through these. And now I want to convert that into square centimeters. So I say 94 inches squared, and then I do my conversion factor. My conversion factor is first that 1 foot is equal to 12 inches. So 1 foot equals 12 inches. And then I want to ask myself the question is, do I need to square this conversion factor? Because I have a square here in the inches, and I want this to also be squared, that means that the entire conversion factor needs to be squared. All right, this is a good example because we're going to have to actually square multiple conversion factors in this case. Then the inches squared here will cancel out with the inches squared here, and I'll be left with an answer that's in feet squared. But I need to convert it to centimeters squared. So I use my next conversion factor, which is that 1 meter is equal to 3.28 feet. But this conversion factor also has to be squared because I want to cancel the feet squared with the feet squared in the denominator here. Okay? And then finally, I want to convert the meters to centimeters. So in 1 meter, there are 100 centimeters. And so I'll need to square that as well. And then that'll give me the final answer. Let's say 124, 9. I don't know what the answer is. Let's see. It's probably 600. I don't know. What is the answer for that one? Number 11. Is it B? I think it's B. All right. Is that right? I think that is right. I'm going to go and write 604. Okay? That's right? Yeah. Now, sometimes, like say for example, I have, I don't know, I've asked a question in the past where I have, say, 35 milliliters cubed per second, and I want to convert that into some other unit. My conversion factor, which would be milliliters, say cubic meters, I would need to cube that conversion factor. No, that's not a good example. Milliliters per, what's another measure of volume? Ounce, to an ounce. I would need to cube just that conversion factor, but when I'm doing the, say, seconds to hours, I don't cube that conversion factor because seconds isn't cubed here. All right? Okay. What other particular things? You'll feel comfortable with the free response? Okay, let's go with the free response. We've done some like these in class, but as I told you in class, the best indicator of what will be on the exam is what we have on the fall 19 exam. Where is that? Yeah, so this is the fall 19 exam, and this is the best indication of what you'll have. That is that your very first problem will be a problem that's practically identical to problem number 1. Because I really want you to know that problem, how to solve it. And when I say that problem, what I mean is a problem where I have an object that I take and I throw up into the air, it goes up, and it comes back down again. Tell me your name.
Austin.
Huh?
Austin.
Austin. Okay, Austin. Good to see you. All right. I really want you to know how to do that problem. So it's going to be pretty much exactly what I have here. That is, I'll probably ask you, what is the total time for the ball in the air? An alternative to that is I could ask you, how long does it take for the ball just to go up to the top? That's something that you have to solve for anyway. And then what is the maximum height of the ball's path? I'm going to ask you that. What is the velocity at a particular time? And then I will ask you the velocity versus, to draw either the position versus time or the velocity versus time for that motion. That's a problem we've worked a number of times, and that's a problem that you're going to have. Let's just work through it right now. Okay, so I want that first problem. I find that if you know the very first problem, it just sets a good tone for the rest of the exam. You don't get flustered right out of the gates, and you just tend to do better. So what is the total time for the ball in the air? Remember, working this problem, it goes up and it comes back down. I know a few things. I know the initial velocity for this ball is 32. I know that the velocity at the top is equal to 0, and I know the acceleration in the y direction is equal to minus 10 meters per second squared. So for part A, if I want to know the total time, I would say that V is equal to V naught plus AT. That's V top. So that's 0 is equal to 32 minus 10 times t. And I solve that for t, and I get to 3.2 seconds. Now that's t top, and this is actually asking for the total time. So the total time, which I'll call t tot, is equal to twice t top, or 6.4 seconds. All right, I'm going to circle that answer. It makes my job a lot easier when I'm grading them, if you'll circle your answer. So that's the first question. The next question is part B, is what is the maximum height? In order to do that, I would say y is equal to v naught t plus 1/2 at squared. In this case, I know everything but y. So it's really just a matter of plugging in the right numbers. V naught is 32. T, well, this becomes a question, because do I put t is equal to 3.2 or t equals 6.4? But since I want to know the position at the top of the trajectory, then I put the time at the top of the trajectory. So that's going to be 3.2 plus 1/2. Be careful that you get your acceleration to be negative here. It is negative. If you don't do that, you'll get it wrong. Times 3.2 squared. And that is 51 meters. All right, so it goes up to a maximum height of 51 meters. Just some things to check out. Make sure you get this negative. Make sure that you don't forget the square. And make sure that you get the time right here, because we already have a couple times floating around in this problem. Make sure you don't use 6.4 instead of 3.2. Yeah, Austin. So, yeah, I didn't really say that explicitly, did I? So to get the 6.4, the 3.2 seconds is at the top of the trajectory. The reason that's at the top is because I know that the velocity at the top is equal to 0. So that's sort of a fixed point where I know what the velocity is. And that allows me to solve this equation then for this unknown. Because I know what V naught is. That's given in the problem. That's the initial velocity. And I know what the acceleration is. That's just a given because we're in the y direction. And so that acceleration is negative 10. It's the acceleration due to gravity. So when I solve for that t top, since it's at the top of the trajectory, the time to go up is the same as the time to come down. So I know I have to double that time. 3.2 becomes 6.4 times 2. Okay, good question. So watch that. C, which you'll have a similar question, just asking what is the velocity. I could ask what is the position at a particular time, but it's just simply a matter of I want you to solve or to realize that these are parametric equations, and if I want to know the velocity or the position at a particular time, it's really just a matter of plugging in to these equations. So that's V naught is, it was 32 meters per second, minus 10 times 1.6 seconds. That was just the time that I gave you. And so that's 16 meters per second. Wasn't it 1.6? Question? Yeah, 1.6 seconds. 16 meters per second. And then recognize that it is plus 16 meters per second, or you might say 16 meters per second in the upwards direction. That would be the magnitude and the direction. Lena?
Can you just find that based on where the time that they give you? Like say the top is 3.2, so...
Yeah, what we're not in part C. I give you the time. I want to know at that particular time. And that's the way it'll be on your exam too.
I just have a hard time like figuring out what I'm supposed to use, like a positive velocity versus a negative, and the same thing with acceleration.
Yeah, I understand. Your velocity, your initial velocity on these problems will always be positive because it's always going to be going up at first, or sometimes it's going to be 0. Now, that's not going to hold in the next chapter. We'll see some special cases.
So say question C said that it was at like 4 seconds.
Right.
Then it would be negative.
You're right. Yes. The reason it would be negative, your velocity would come out negative, is because I've passed over this topmost part, and then the ball is going to be going down. But when you solve that equation, you don't really have to think about that. That's a good check to see if you got the answer reasonable, but the equation will give you a negative velocity. Let's just try that. So what if I ask, what is the velocity at 4 seconds, as you said? So that's 32 minus 40. That's negative 8 meters per second. So you see, it's going to come out negative. But that's a great way to check your answer, because if it came out positive, you might say, oh, I bet I didn't put my acceleration in as negative, or something like that. Okay? And then finally, for part D, you have to draw a graph. I'm either going to make you draw this graph, V versus T. Isn't that right? Yeah, that's right. Or I'm going to make you draw this graph, Y versus T. The Y versus T looks like this. Okay? Make sure you know those. You need to know those graphs and be able to interpret them and transition between the two different ways of representing the motion for all the rest of the exam. But make sure you get this one right, because it's either going to be one or the other. All right? It's that one or that one. That's what I'm going to ask you to draw. Okay? You can do that, right? What would the acceleration graph look like? Yeah, we haven't done that, have we? The reason I haven't done it is because the acceleration in the y direction versus t will always look like this, where this has a value of minus 10 meters per second squared, because the acceleration in the y direction is always constant. Yeah, we don't deal with a changing acceleration. That makes problems quite a bit more complicated when you have a changing acceleration. Do y'all know what the rate of change of acceleration is, by the way? Like, the rate of change of position is velocity. The rate of change of velocity is acceleration. Do you know what the rate of change of acceleration? That would be in a meter per second per second per second, or a meter per second cubed. You know what we call that? Never thought about that, have you? It's called jerk. What is the jerk of a system? And that's the rate of change of acceleration. That's a real thing. Yeah. It's not just a good movie. Have y'all seen The Jerk? No. It's from the late 70s. It was with Steve Martin. It's a classic. It was like the height of his comedic career, The Jerk. Check it out. All right. So you'll have a question like that. And then you'll also have a question like number 2. Not exactly like it, but it'll be exactly like it in the sense that it will be a system of 2 equations with 2 unknowns. I'm going to work through this one. We've worked through this one before. And I'll tell you in that it's not going to be exactly like it, in that the variables that you know and don't know aren't going to be the same as this one, but it'll work very similarly. So the first step is to write down everything that you know and what you need to know. So you have to read the problem carefully. I'm going to write it up here above the words. The truck covers 100 meters. That's x. X is equal to 100 meters in 10 seconds while smoothly slowing down to a stop. And this is where you need to think, okay, what's going on here? It's slowing down to a stop. That means that my final velocity is equal to 0 because it's coming to a stop. And my initial velocity, well, I don't know that. In fact, that is the first question. What is my initial velocity? And then finally, what is the acceleration? I need to know the acceleration. Okay, so I don't know x. I do know x, t, and v, but I don't know a and v naught. So I'm going to write my 2 equations. V equals v naught plus at And I really want y'all to do the same technique as just the way that you work through this. And then x is equal to v naught t plus 1/2 at squared. I'm going to go through and just mark my unknowns. You don't have to do this on your test, but I'm marking my unknowns, v naught and a, v naught and a. It's usually easier to begin with this equation just because it's a less complicated equation because I don't have that quadratic term, that t squared. So I'm going to write this, 0 equals v naught plus a times t, which is 10. I'm going to write this as 10a. I just switched the position of a and t, 10a. Okay? I'm going to do the same over here. I have 100 equals v naught times t. That's 10 v naught plus 1/2 at squared. T is 10, so that's going to be 50a. You'll see how I did that? I did t squared, which is 100. I did 1/2 of that is 50. All right, so now I have two equations. Each of them have two unknowns. Now on this one on the left, I'm going to say that v naught is equal to negative 10a. I'm just doing that one because it's really simple. Now I'm going to take this negative 10a, and wherever I have a v naught in the other equation, I'm going to plug it in right there. So that's going to give me 100 equals 10 times negative 10a plus 50a. Is that right? Yeah, plus 50a. Am I losing y'all? Okay. I know it feels like you're just swimming in a sea of numbers for many of you. It does feel that way for some of you, many of you maybe even. But when you practice this, it'll become more regular, more familiar to you. All right, so this is 100 equals negative 100a plus 50a. I only have one variable here, so I can solve for it. 100 is equal to negative 50a, so a is equal to negative 2 meters per second squared. Now that makes sense because I have this object, this truck that's traveling in a positive direction, and it's slowing down, so my acceleration should be negative. Now once I have that first variable, it becomes pretty easy because I take this value for a and I plug it in right here. So I already have an expression for v naught. It's equal to negative 10 times negative 2, and that's equal to positive 20 meters per second. So that's v naught. Really, I want to see that you can solve a system of two equations. We're going to have to do that in chapter 4 when we get there. I just want to see that you can do the math. Now, the kinematics is important too, and really that just comes into making sure that you get these variables assigned correctly and that you know these kinematics equations for v and x. But the main part of this problem, or these two problems in fact, are that you can solve this system of two equations. Okay? I think solving them in this way, where you write the two equations at the top, and then you sort of solve them in two parallel columns going down, is probably the most orderly way to do that. That helps you, when you keep order with everything, it'll help you to sort of see what you've done. Okay? Yeah. No numbers. Is that what you're asking? Do I want numbers? No numbers. And every year somebody writes numbers, but I don't want numbers. I just want a sketch. I want you to give me either this graph if I'm asking for velocity, or this graph if I'm asking for position. No tricks. That's what I want. Okay? No tricks. Especially on the free response. Okay? I want everything clear about what I'm going to ask, because I want you to walk in, know exactly what I expect you to do on those first 8 questions, and get them all right. How many are you going to get right? All of them. How many? Oh, oh, yes, that's the right answer. You're going to get all of them right. Okay? Um, Now, on this last one, where I'm asking you to interpret a graph, it might not be a velocity versus time graph. Honestly, I don't remember what I gave you. It could be a position versus time graph. But in those, if I give you a position versus time graph, position versus time, say x versus t, remember there are a couple things that I could ask. First, the slope is equal to the instantaneous velocity. That's where if I give you a graph that looks like this, and I ask you, say, for the instantaneous velocity at a point there, you draw a tangent line, and then you find the slope of that line. Be careful that you do not count the squares, because I often like to not let the squares be the same on the x and y axes, because that way if you count the squares, you're going to get it wrong. Notice here, yeah, I did that here, that the y-axis, the squares were a unit of 4, and the x-axis, the squares were a unit of 0.5. Do not count the squares. Use the x and y axes to figure out the rise and the run. Okay, so that would be one thing if I gave you a position versus time graph. The other thing is to find the average velocity. Now remember, the average velocity is delta x over delta t. So for example, if I'm asking the average velocity, but say between this point and this point, you don't worry about the function in between. You're really just trying to find the slope of that line. You figure what is x final, what is x initial, and you take the difference in those, and then you do the same for the time. Or you can think of it, I'm just looking for the slope of this line. So if I give you a position versus time graph, that's likely what I'm going to ask you. If I give you a velocity versus time graph, I'll ask you, what is the acceleration? That's found from the slope. And then what is the distance traveled? And that's found from the area, like we did in this problem before. You're going to have one or the other. And if you look back in the old test, you'll find lots of examples of each as you go through the old test, because I always ask questions like this, the graphing questions. That's a third of your exam or more. A little less than a third of your exam, but nonetheless, an important part of your exam. It's also a great place where if you mess up a little bit, you can still get credit for them. But don't mess up, because you know exactly what's going to be there for this part of the exam, and I want you to get it all right, 100%. It sets a good tone. It'll make you'll do better on the multiple choice if you do well on this part. So spend a lot of time making sure that you got these down cold, that you don't even have to think about them. You can just go in and finish it right away. Okay? Right? That's what you're going to do? Yeah. Right.
So, what if approximation of like the area and stuff? What if you have, like when you're looking for the area, do you recommend finding the area first or converting each side first? Alright. For example, if I want on velocity 60, it's number 1.
Which one was that? Was that the coffee cup?
Mattress.
Oh, the mattress, yeah. Yeah. Well, I think with the mattress, meters squared are what you would typically think of to find the area of a mattress. So if I have a mattress is usually like 6 feet on one side, right? That's 2 meters, right? A meter is approximately 3 feet. And this is approximately 1 meter for a twin mattress. So that's going to be 2 square meters. It's also helpful to think, look at these squares. These squares are about 1 square meter. In fact, these squares are 1 square yard, but a yard is really close to a meter. So a twin mattress is 2 of these. You can think too of, say, a cubic. If I ask you a volume question about centimeters, a cubic centimeter or milliliter is about the size of a sugar cube, right? You know what a sugar cube is? Those little cubes of sugar. Those are about a cubic centimeter. So sometimes you only really need to think about conversions or doing any calculations. I can just envision in my head how many of those would fill a certain space or fill a certain area.
So you're saying like find, because the way that I thought about it was I compared it to like myself. And I was like, okay, I'm like 5'6", it's probably around 6 foot, and then I converted it.
Yeah.
So I shouldn't multiply the sides first and then convert it? I should convert it and then.
I would convert it to meters first. I mean, I think that's what you did in your head. You said, "Oh, I'm about 6 foot tall. 6 foot is about 2 meters." I mean, you're not quite 2 meters tall. 2 meters is pretty tall, but you get the point. That we're doing an estimation. Students have difficulty with these, but if you're familiar with the meters, the centimeters, the kilograms, then you should be able to get these without much effort. I will try to give you an object that is really familiar to you, or I'll give you a picture of an object on the test. I know that sometimes people, like I did the coffee cup thing a few years ago, and that was a tough question, because people weren't real familiar with the size of a coffee cup. But you should. A coffee cup's this big, right? And this big around. Okay. Remember, the estimations are all going to be order of magnitudes. That means by factor of 10. So the answers that are on either side of the correct answer will not be reasonable. They won't be reasonable at all. That it's going to be a factor of 10 more. Whew. Okay, so chapter 1, you have a 1 or 2 trig questions. I don't think I listed that on the first thing. You'll have dimensional analysis. You have several questions. You'll have one like this where I give you several equations, and then one like this where I ask you for the units of a variable in an equation. Conversion, you'll need to know your standards. Okay, make sure that you're familiar with the standards in such a way that you can even spot incorrect standards. Like the standard for the meter is based on the distance that light travels, but notice that some of these others are similar, like B is the standard for time, the frequency of a cesium atom, but here it's applied to a meter, and so it might confuse you if you're not real clear on what those standards are. Or the standard for the meter used to be the length of a bar in France. C was, they were considering the standard for the kilogram to be a silicon sphere a couple of years ago, and so that's why this question is here. But we didn't really talk about the silicon sphere, so you won't see a silicon sphere on the exam. Okay. Number 11 here gets into chapter 2 questions. You'll have some, or this will be your free response, for example. Number 11, you will have some calculations in the multiple choice for kinematics, like number 12, for example. Can we work through number 12? Is that okay? All right. So this is this fall 17? Fall 16? Okay, so it's a good example of what you'll see in your multiple choice for kinematics. Let's write what we know. I'm going from an initial velocity of 5 meters per second. I'm going to leave off the 0.00, but I will recognize that I have 3 sig figs here, 4 here, and 3 here, so my final answer should have 3 significant figures, but I'm going to leave them off just to make it easier to write. The final velocity is 30 meters per second. The time is 0.02 seconds. That's 2 times 10 minus 2. And I want to know what is x equal to. Now notice that I can't right away solve x because I don't know the acceleration. Right? Because if I write the equation for x, it's v naught t plus 1/2 at squared. But notice that I don't know x and I don't know a. Now this isn't a problem that's the same as the free response. This one's a bit simpler, but it's still a 2-step problem. The way that you would do this is you would say that v is equal to v naught plus at, and I would solve for a. A is equal to v minus v naught divided by t, or you could put in numbers and that's okay. 30 minus 5 divided by 0.02. That's 25 divided by 0.02. That's 1250. So that means my acceleration is 1250 meters per second squared. So now I can solve for x. X is equal to 30 times 0.02 plus 1/2 of 1250. Good example of when the acceleration is not negative 10, right? Because I'm in the horizontal. And then t is 0.02 squared. Be sure to get that squared. Often I'll have an answer down here for students that don't square their time. And that's going to be 30 times 0.02 minus, what's that? 625 times 0.02 squared. That's 0.35 meters. Okay? Probably going to have a problem like that. I usually do. I have a kinematics problem that requires 2 steps. Not a system of 2 equations with 2 unknowns, although this is technically, I guess. But it doesn't require substitution of one equation into the other. That I only have to solve for a variable here and then plug it back into the equation here. Okay? These will be important skills for you to master before we move into the next chapter. So I really want you to master these now, these algebra skills, because when we get into chapter 4, we're going to be dealing with some difficult concepts and then also similar algebra skills. So I want you to develop those or remember those skills now. You have them, they're just buried deep. Okay? Oh boy. So, yeah. Number 14. Oh yeah, oh goodness. So this was from a concept test. We had a series of 2 or 3 questions that were based on this. You drive for 30 minutes at 30 miles an hour, and then for another 30 minutes at 50 miles an hour. What is your average speed for the whole trip? So when I drive for 30 minutes at 30 miles an hour, I'm driving a certain distance at 30 miles an hour. And then at 50 miles an hour for 30 minutes, I drive a shorter distance, 50 miles an hour. Why do I drive a shorter distance at 50 miles an hour? I'm going faster, right? For 30 minutes. But when I average these together, because I'm traveling the same amount of time, 30 minutes for each segment, I'm going to get an average that's equal to 40 miles an hour. If you don't believe me, you can figure this out. So in this first leg, I drive 15 miles. And then in this second leg, I drive 25 miles. Right, 50 miles an hour for a half an hour, that's 25 miles. So the average velocity will equal to delta x over delta t, which is going to be 15 plus 25 divided by 1 hour. That's 40 miles an hour. Okay? Yeah. Oh, don't worry about the runners. I think I actually pulled that question from their exam. There was a mistake in that so just makes it. Although, when you might run, you'll run. You used to, okay. When you run, if you travel at a slower speed, it has a greater impact on your overall average speed. That your overall average speed will decrease more than because you're running slower and you run for a longer distance over that time. Kind of like here. But there was another question on the concept test. And another question on the concept test was similar, but it said that you drive for, say, I don't know, 30 miles at 30 miles an hour, and then 30 miles at 50, oh, let's do 60. 60 miles and 60 miles, oh, that's not good. We'll do 150, sorry. So you drive 150 miles at 30 miles an hour and 150 miles at 50 miles an hour. See how that's different? That I'm traveling the same distance. And in these cases, I'm going to be traveling for a longer time at the 30 mile an hour speed. And because I'm traveling at a longer time at the slower speed, it's going to make my average go smaller. I'm going to have a slower average. So in that case, the answer would be less than 40 miles an hour. Okay? Look back at the concept test. The concept tests are great, those PowerPoints. I posted them on Moodle because they have extra explanation. Might help you to remember the answers better, understand the answers better. Okay, what else in particular? So chapter 2, make sure you can do things like number 19. You'll certainly see some like that. Number 18, number 20. Holler if you want me to do something like that. Number 20 is a hard question. Can we just look at number 20? I don't remember if I have one like number 20, but there's just a lot in number 20 for you to think about, so it's a good one to look at. On questions like this, just begin going through all the different options, and then you should be able to eliminate some of them. So here for A, the object is traveling at a constant speed. Right here? Not really, because really the object is not moving at all. So I'm going to say that one's not true, because the object is not moving. See, its position is always the same over time during that region, and so it's not moving. For B, the object has a negative acceleration. Well, let's see. Has a positive slope, so it has a positive velocity, and it's speeding up. So that means that the object has a positive acceleration. And in C, the object is increasing position at a constant rate. Is that true? That is true. Very good. So that's true. But A is not correct. In fact, when I saw that the first one was not correct, I could have just moved on to B. Here, the object is not moving. That's correct. The object has an increasing speed in the positive direction. Yeah, we just said that was true. And the object is traveling at a constant positive speed. Yes, because the slope of this section is positive. So that is the right answer. So it seems like a lot, but when you start going through the answers, you'll see that it's not that hard. There's just a lot of words there. Let's look at these others. The object has a constant non-zero velocity. Not true. It's stationary. It has a zero velocity. The object has an increasing position. Well, the position here is right here. The position up here is more. So yeah, it does have an increasing position. The object has an increasing speed. Right here, no, the slope is the same. So the speed is constant. So that's not true. The object is in the same position. True. Yeah. The object has a positive acceleration. True. We just said it was. The object has an increasing speed. Not true. So B is the only one with 3 true statements. I like those kinds of questions where there are multiple statements you have to say, are they true or not true? Those are difficult questions, though. You have to think about a lot of different things. Some questions will take longer, but on average, you shouldn't take more than 2 minutes on any. No, I take that back. On average, yeah, no more than 2 minutes. Some questions will take you maybe 3 or maybe even 4 minutes, but some questions you should just be able to read and answer like that without any thought at all. That it's just be cold to you. You know it so well that you don't even really need to think about it. Okay? Usually takes me 20 to 25 minutes on the videos to work through them, but that's with a lot of narration and stuff. So if you know it really well, you should be done in 20 minutes. Now, in practice, I don't think any student will finish after 20 minutes. So take your, you'll have enough time if you know it. Just take your time, but don't dilly-dally. All right, particular questions. You're going to have vector question like number 25 and 26 for sure. Absolutely like 25 and 26. And then you'll have some conceptual vector questions like number 27, for example. Y'all feel comfortable with the vector questions? Y'all holler if you want me to do them. I will. Number 25, yeah, you're going to have one like 25. Okay, you hear me? You will have one like 25. There are 3 steps on these. 1, you find the x and y components. 2, you add the x and y components. Or you add the x components, you add the y components. And then 3, you find the magnitude and direction. Or usually it's r direction. I'm usually just asking for one of those. All right, so the first step is I find ax and ay. AX is 4 units along the negative x-axis. But that means that AX is negative 4. And AY, because that vector is only on the x-axis, is 0. And then you find BX and by. Now you will have one vector on axis and one vector off axis. In this case, vector A is the on axis vector. Bx is going to be 12 cosine 30, and by is going to be 12 sine of 30. I'm going to check, make sure that they're positive or negative. This vector is above the plus x-axis. That means it's in the first quadrant, so both of those are going to be positive. So that's going to be 10.4, I'll just say 10, and 6. That's step 1. Step 2 is to add up ax plus bx is equal to negative 4 plus 10, or 6, and ay plus by is equal to 6. Okay, so now for part 3, I want to know the magnitude of this new vector. It's going to be the square root of 6 squared plus 6 squared. Is that the square root of 72? Which is 8.48. Yeah, I rounded up here. 10.4. I'm just going to look up the answer. I'm going to cheat. 25. But you do not cheat. You don't know the answer. So C. If I don't round, it should be 8.77. Sorry, I try to check that. I don't want rounding to distinguish between your answers, but really I should have kept 3 sig figs all the way through. My bad, I'm sorry. So this should have been 6.00. But I'm usually pretty careful about that. I don't want rounding to leave 2 answers in the lurch. Okay? By the way, what would be the angle for this? Well, if the components were 6 and 6, what would it be? Come on, y'all. Oh, no, yeah, you're right. You have to do the inverse tangent, but I mean that's a special triangle. One where both sides are equal. Call it an equilateral right triangle. No. Come on, y'all know that. Equilateral right triangle. What are the angles? 45 degrees. All right, 45 and 45. Don't worry, we'll get in chapter 4. We're going to get much into that. You'll see a lot more trig. You're going to love chapter 4. Like chapter 3, you're going to like a lot, but then you're going to love chapter 4. Huh? No, I think chapter 4 is kind of fun. No, it is a little sarcastic. It is probably the most difficult chapter. Exam 2 is the most difficult exam this semester. And exams 3 and 4 get a little bit easier. They get quite a bit easier, actually. This is probably one of your... This might not be the easiest exam, but it's close. Okay? You'll have one like 26, too. Let's just do 26, because you'll certainly have one on every exam. I draw the vector A first. There's my vector A. Recognize that this is a negative here, so I'm going to draw the opposite of B. So there's my B. This is A minus B. And then the sum of these two vectors, or the difference rather, looks like that. And so that's A is the answer. Notice that if you draw them in different ways, you'll get B, C, or D. All right, so if I drew my vectors, I don't know, A, B, I'd get a vector that looked like that, which would be the option B. So if you draw your vectors incorrectly, you will get one of the other answers. Be careful. That's usually the case on all the questions, that if you make a common mistake, you will get one of the answers. There are only several mistakes that you can make on every question. And when I make the questions, I'll go through and make those mistakes for you and put those as answers. You're welcome. That takes a lot of time. And so,
what if you had like B minus A instead?
If I had B minus A, yeah, let's try that. B minus A. So B is right here. Minus A is just the opposite of A. So it looks like that. And so the resultant looks like this. So it would be C would be the answer for B minus A. Now be ready to do that. It could be a difference. It could be a sum. Sometimes I double one of the vectors. I didn't do that for y'all, but should know how to do that anyway. Like if I had 2a minus b or something, where you just make a twice as big. But I didn't do that on this exam. Okay? The way it'll work on the day of the exam is you'll come in, you'll have assigned seats, and I'll have a roll out front where you show you where your seat is, and you will, it'll be your bubble form, just like we used on the quiz, will be stapled to the front of your exam. Make sure you know your N number for that, by the way. I'll probably send out a video reminding you how to do your bubble form. You'll tear that off. On one side, you'll have your bubble form. On the other side, you'll have your free response. Your free response, you can write on that side of the paper as much as you want. If you run out of space, you can flip it on the other side, on the bubble form side, and you can write in that block that I'll put on the bubble form, just if you need the extra space. Usually students don't need that, but if you do, you'll have that. And then the multiple choice will be all the pages that follow. You can, like I said, tear those pages apart so you can write your answers on your bubble form. You can write, of course, on the multiple choice. I really encourage you to write on the multiple choice. I find that usually the students that make A's are the ones that write on the test a lot. They're able to spot mistakes when they write them down more easily than if you're just doing them in your calculator. It's hard to see mistakes in your calculator. Okay? Yeah, class time, 10:45. We'll start at 10:45. I'll give you till 11:45. So you get an extra 5 minutes to account for sort of, shuffling papers and stuff. Okay? You'll do well. You're going to do really well on this first exam. I know it's been a hard month, but you can do this. You got it.